Welcome to Study Loop.
Okay, so we know the total mechanical energy is equal to 1/2 ma squared omega squared. And total mechanical energy can be also equal to the kinetic energy plus the elastic potential energy, which is 1/2 mv squared plus 1/2 kx squared. And as you can tell, the angular velocity can be equal to square root k over m, which is square root spring constant over the mass. So therefore, k is equal to m omega squared. So if we plug it back to the equation here, we have E is equal to 1/2 mv squared plus 1/2 m omega squared x squared, which will have 1/2 m a squared omega squared is equal to 1/2 mv squared plus 1/2 m omega squared x squared. And as you can tell, 1/2 m can cancel out. So therefore, a squared omega squared is equal to v squared plus omega squared x squared. In the question, it was assuming that the kinetic energy is equal to elastic potential energy. So therefore, we have such statement here. So if k is equal to u, so we have 1/2 mv squared is equal to 1/2 m omega squared x squared. As you can tell, 1/2 m can be cancelled out. So therefore, we have v squared is equal to omega squared x squared. So therefore, we can substitute omega squared x squared for v squared. So we have a squared omega squared is equal to omega squared x squared plus omega squared x squared. So eventually we have x equal to positive negative a over square root 2. So the magnitude of the displacement is a over square root 2. So we know the velocity can be equal to positive negative omega times the displacement. Therefore, we have positive negative omega times positive negative a over square root 2, which will have omega a over square root 2. And this is the magnitude of the velocity, okay? And velocity is equal to omega a over square root 2. And for the next question, so this graph here indicates a complete cycle, okay? As you can tell, it's from 0 to a, and then from a to 0 again. And then from 0 to negative a, and then come back to 0. So which means that the displacement x will be equal to positive a over square root 2 twice, and also equal to negative a over square root 2 twice. So therefore, the potential energy match with the kinetic energy for 4 times in one cycle, okay? So the time period for one complete cycle is t. So therefore, the kinetic energy is equal to potential energy 4 times each circle or each cycle. So the time difference between the two successive events must be, since there are 4 times happen, and you know in one cycle there's the period is one t, which is t here. So since it happened 4 times, so each time it should be t over 4. So the answer is t over 4. And for the last question, well, the last question was saying that what is the fraction between the kinetic energy and potential energy in the total energy system if the displacement is equal to 1/2 amplitude? Well, we know total mechanical energy is equal to kinetic energy plus the elastic potential energy, which is equal to 1/2 m omega squared a squared, and then equal to 1/2 m v squared plus 1/2 m omega squared x squared. And so in this case, the displacement is equal to half the amplitude. So therefore, we have x squared is equal to a squared over 4. Or you can say 1 over 4 a squared. Which means that we'll have something like this, which is 1/2 m omega squared a squared is equal to 1/2 mv squared plus 1 over 4 times 1/2 m omega squared a squared. Okay? Because remember this, x squared is equal to 1 over 4 a squared. So therefore, when the elastic potential energy is actually equal to 1 over 4 total mechanical energy. So therefore, we have E, which is 1/2 omega squared a squared here, is equal to 1/2 mv squared plus 1 over 4e. And we know kinetic energy is equal to 1/2 mv squared. So therefore, I'm sorry. So therefore, kinetic energy K here can be equal to E minus 1/4E, which is, which is 3/4E. So these are the fraction of kinetic energy and the elastic potential energy in the total energy system. Okay, so the elastic potential energy is equal to 1/4E, and the kinetic energy is equal to 3/4E, which is 3/4 the total mechanical energy. So these are the answers.